All right, so the program structure goes back to the modularity model.
Right.
So if you remember back in C++ when we kind of showed you this, it's similar. So here we have like a larger main object.
Right.
And a bunch of supportive objects that kind of spawn off of that. Then we have the modularity enhanced model, which is like C++ and Objective-C, where we have, that main object, but then you have other objects with objects inside of those and smaller objects that kind of on their own, and they can all talk to each other and have them all orchestrate whichever you want. Then you have the object-oriented model, which is more Java and C#. And this is where that main function is inside of a larger containment object that contains classes that then make references to other classes that contain other objects and so on and so forth.
It kind of looks like the universe when you look at it from this. It's like, or like cells, like
bacteria.
Yeah.
I'm gonna eat them all. So let's talk about our working environment for the sake of the labs in this course. The operating system we're going to write in is going to be Microsoft Windows. We figure it's probably going to be the most common that you'll have, and we want to show you the most common environment that most likely one you'll be familiar with.
And also, those of you guys running Unix and Linux, I mean, you're usually like a more advanced computer user, and you know how to run, you know how to install this stuff. You can follow all of this stuff in Unix and Windows, but
the Windows people can't follow Unix as well as Unix people can follow Windows. Right?
Precisely. There you go.
So if you're running Linux, you know what's up. You're fine. If you're running Windows, we got you covered.
You know what's going on.
So we're also going to be using the Java Development Kit, which we talked about, and we'll get directly from Oracle, and we're going to use our trusty old ASCII text editor, Notepad++.
We're coming back to Notepad++, baby.
So we'll show the process using this working environment as we always try to with our minimalist approach. And then later on in the course, we'll kind of get you up to speed on NetBeans, for example. But for the sake of this, we want to focus on Notepad++, the JDK, and kicking it off.
The way that we see it is if you can code it here, you can pick up an IDE.
Oh, yeah, absolutely. Like you can jump to whatever you want, right?
Now, if I were to show you a Hey Buddy program here in Java, how do you feel about it? I mean, does this make you feel happy? This is not what we've seen. What the is this?
This isn't so much a hey buddy, it's more of a hey buddy.
Maybe we should have put a question mark.
Hey buddy. Okay, so let's break down what we have here. What's going on here? This is a little static void main inside of the class.
Open it up and let's sniff around. So
let's get up in that just spray paint in there and just
any class in Java that has a method that is public and static and void and called main is the main class.
The entry point.
Yes.
And there can only be one.
There can only be one. So this class, Hey Buddy, is the name of the class, which would be our main class declaration.
So this public static void main. Public static void main. Public static void main. Nail that down.
Yeah.
That will always be our entry point for the program. Only one of them.
And look at this, Brian. It's encapsulated in an object right off the start.
So right, exactly.
Beautiful.
Yeah. And it's not instance level, it's static.
Right, yeah, because we don't instantiate, you can instantiate the main class,
right.
But in order to define an entry point, you don't instantiate the main class. Right. So here we have the system class. Now inside the system class has all kinds of members, whatever, instances or whatnot. So we're going to be evoking the system class and evoking its static member inside of it. And the static member is
print stream.
Well, it's out. A print stream, but it's out.
And then inside of out.
But hold on.
Oh, sorry. Oh, this replaces std out. So this is like cout. It's a print stream object. It's similar to what we saw in C++.
Yeah, and we'll start talking about later what a print stream object is. But in the system.out context, out represents standard out. And as you'll see later, you can actually redirect this because a print stream can go to anything.
So any handle. We
can easily switch this to anything we want.
And inside of this object, there's a method called println. So instead of printf, we use println. And println exists inside of the out object, which is inside of the system object, which by default is pointed to standard out.
Right.
This can take just a single string, hey buddy, and print it out to the console, or whatever standard out is pointed to.
So this is more like puts, because when you think about puts in C, it writes out your string and then it puts a new line.
Exactly.
Same thing here with println.